Thank you for joining this session. I want to talk about Gemini embeddings and the open EmbeddingGemma model. I'm Patrick. I'm a DevRel engineer at Google DeepMind. I'm actually based here in Berlin, so that's why I'm super excited that we have an event like this here. Yeah, that's my talk. And here's the overview. So I want to talk about both models. I'm starting with Gemini Embedding, give you a quick model overview, how we trained it, and then some of the controls you have with it to make it especially efficient for vector search, like controlling the embedding size and specifying task types. And then also I want to show you how to actually build with it, show you some code examples. And then the second model, EmbeddingGemma, also give you a quick model overview and show you how to use it. So yeah, let's dive in. First of all, this is the Gemini ecosystem. A rough overview. We have, of course, our main Gemini series. Right now we have the 2.5 series with 2.5 Pro being our most capable model, then 2.5 Flash, which is what we call our workhorse model, really good for everyday tasks, and then Flash Lite, which is even more cost efficient and super fast, and then we have Nano for on-device stuff. And we actually don't talk a lot about embeddings, but we also have a Gemini embedding model, so that's why I'm excited to talk about this one today here. Before I go into the Gemini embedding model, actually I want to tell you about our mission for the embedding model. So the mission is to create an omnimodal, Gemini-derived, retrieval-oriented representation to complement Gemini's capabilities. So omnimodal, this should in the future work across text, images, videos, audios. This is the mission. Right now we're only at text embeddings, but in the next iteration I think you can expect to have a multimodal embedding model. And here's the rough overview. Gemini Embedding is a powerful model for creating high-performance text embeddings. It supports over 100 different languages. And it features Matryoshka representation learning for flexible output dimensions, starting at 3072, and then you can go lower. And right now it's holding a top spot on the massive text embedding benchmarks, which I'm showing in a moment. Here's the paper. This came out in March, so you can find it on ArcSci, for example, and read more about it. I want to give you a high-level overview of how we trained this, roughly in 3 steps. So we have what we call the pre-fine-tuning step, step 1, where we take one of the Gemini models and adapt the parameters for encoding using a billion-scale web corpus. Then step 2 is the fine-tuning step. So there we fine-tune this on a diverse mix of high-quality task-specific data sets. And then step 3 is what we call a model soup. So we take all these multiple fine-tuned models and then average them to create one final, more robust, more generalized model, which is the Gemini embedding model. And what's also interesting, it's trained by Gemini. So we use Gemini a lot in the process for the data generation and data pre-processing. Specifically for synthetic data generation, and then also data filtering, where Gemini acts as what's called an autorator to remove, for example, low-quality examples, and then a technique that's called hard negative mining, where Gemini finds tricky examples to make the model smarter by training it on these samples. And performance, yeah, this is also a slide with some benchmarks. It was mostly evaluated on the massive multilingual text embedding benchmark. And ever since we released it in March up until now, it's holding the top spot on the multilingual one, on the English one, on the code one. And then we also evaluated it on the XOR retrieve and extreme up, for example. So yeah, it is a very performant model. You can actually also test this as an openly available benchmark that you find on Hugging Face. And this was a screenshot taken yesterday, so Gemini Embedding currently ranked 1. But I would actually also want to highlight is you also find the EmbeddingGemma in here in the top 10, which is really, really nice to see. And what specifically stands out is if you look at the column with the memory and the number of parameters, so basically the first 2 rows after the accuracy, then it stands out that this is a super small model, but still very efficient. So it's nice to see this here as well. It was also trained with this process. I think today it should be the standard, so I assume you already are familiar with this, but basically Matryoshka representation learning is a technique that trains a single embedding model to produce a set of nested lower dimensional representations within a single high dimensional vector, and then you can choose if you want the full vector or just a subset of this, and you can truncate the outputted embedding and adapt this for your specific use case. This is MRL in action, so this is actually very widely used in practice now with this 2-pass search approach, where you do a first pass over the entire database with a lower dimensional embedding size and kind of create a short list of your candidates. And then you do a second pass, the re-ranking, where you then take the full embedding size and then do this only on the shortlisted candidates. We actually have a cookbook about this that walks you through this step by step. And this was contributed by a Quadrant engineer, so shout out to Jenny if she's around here. This is on the, you can Google for Gemini cookbooks, then you also land on the cookbooks repository on GitHub, or just take the link here. So there you learn step by step how to do this 2-pass approach and with a vector, with a Quadrant vector search engine. And now I want to show you quickly how to do this from scratch. I'm a developer. Usually I like to do live demos, but today I'm limiting it to the code screenshots. But this is basically all you need to do to run Gemini Embedding via the Gemini API. The starting point for all the Gemini models is AI Studio. Who has not yet heard about AI Studio? Oh, okay. Only a few hands. Yeah, it's nice to see. If I've asked this question maybe 6 months ago, it would be more than half the room. But I think we're doing a good job talking about this. So AI Studio is basically the entry point for developers, the playground to try out all the Gemini models. And this is also the place for you to get the API key. You can use this for free. You can actually not use the Gemini embedding model there in the playground, but this is the place to get the API key. And then we have our Google Gen AI SDK, so the first-party SDKs, which we have in Python, JavaScript, Java, and Go. Here's the Python code example. So you do pip install Google Gen AI, set up your client, and then simply call client models embed content, and use the model string, which is for this one, Gemini Embedding 001. This is all you need. And now I want to show you some of the configurations you can do so you can control the embedding size simply by adding one line with this configuration and then specifying the embedding size or the output dimensionality. By default, it's using the highest ones. Here I've listed all the available ones. We usually recommend to use the one highlighted in blue, so 3072, 1536, or 768, which is a nice trade-off of performance versus accuracy. And the second one you can do is specify the task type, actually, because as I said, it was trained on lots of different tasks. And depending on what you want to do, you can specify this here, and then you get more optimized relationships in the embedding specifically for your use case. So we have these eight use cases. I'm not gonna go over them right now, but it's nice to give you this control when working with the embedding model. And then also, I wanna highlight the batch API, which now has support for the embedding models just 2 weeks ago, so not a lot of people knew about this capability. The batch API basically lets you process the embeddings or calculate the embeddings in an asynchronous way where we take up to 24 hours, so you don't immediately get the result, but you will save 50% actually. So here's the comparison of the standard way. There it costs 15 cents per 1 million input tokens, and if you use the batch API, it's only 7.5 cents per 1 million input tokens. So I think this is one of the cheapest ones you will get right now on the market. And yeah, it's a nice way to know. And then, yeah, this is basically all I want to show about Gemini Embedding. I also want to give a highlight to customers that are already building with this. For me as a developer and developer relations engineer, it's always really nice to see when developers and customers already put this in action. So this is Everlaw, which is a platform for document analysis for law firms. So they have a RAG system over millions of specialized texts, and they build with Gemini embeddings. And then this one is a pretty cool one. Maybe you know about it. It's root code. So if you're a developer, maybe you know about this. This is an open source AI coding assistant. And they use Gemini Embedding, for example, to index their code base and also do semantic search over the code. And we have a full blog post here about some more customer stories if you're interested in that. And with that, I want to move on to EmbeddingGemma. We've, I think, just already seen it on some of the slides from base 10, so thank you for the shout out. I'm a big fan of the Gemma open models. And EmbeddingGemma is fairly new. Who has already heard about it? Yeah, quite a few people, nice. And it's a very lightweight model, so only 303 million parameters, adapted from the Gemma 3 architecture, and yeah, really made for efficient on-device use. I think in the keynote, we've heard that the wave 3 now might be 8 on-device agents, on-device agent systems. And we also recognize that, so yeah, we focus a lot of our research also on on-device models. And here we have the EmbeddingGemma one, so it also gives you the flexible embedding dimensions. And yeah, it allows a lot of really cool use cases for mobile-first RAG systems and vector search systems. So also a quick slide about the performance. So it's currently the highest ranking open multilingual text embedding under 500 million parameters, also on the massive text embedding benchmark. It's also trained on 100+ languages. This is always a paradigm we have for the Gemma model series, to also have it really focused on being multilingual. And it's actually small enough to run on less than 200 megabytes of RAM with the quantized version, which is really nice. And yeah, this is one code example how you can run it. It's available on all the typical platforms like Olama, Llama, CPP. This is the example with Hugging Face and the sentence transformers library. And we also have a cookbook if you want to see the code example that walks you through this step-by-step to build a RAG system with EmbeddingGemma. I'll leave it here for a few seconds if anyone wants to scan. And yeah, we also have a paper about this. This actually came out 2 days ago. So yeah, very new that it's now also available publicly. Feel free to check this out. And this is basically all the summary that you need to know about these two models. So EmbeddingGemma made for on-device, mobile-first offline apps, and then Gemini Embedding for large-scale server-side cloud apps. EmbeddingGemma is the open weights one, Gemini Embedding available via the hosted API, and EmbeddingGemma best in class for its size, whereas Gemini Embedding is really state-of-the-art if you need the absolute performance, and then also comparison of the different available sizes. And with that, these are basically the links you need to get started. to start building right now AI Studio, the entry point to play around with all these models, to get your API key. You can also generate starter code there, and then bring this into your own applications. And then we have these two different documentation pages under ai.google.dev, either /Gemini API or /Gemma, and then find the docs there. And yeah, that's it. Thank you for your attention. I'm also happy to connect. I'm around later on also for questions. So yeah, thank you for your time.